Okay, I'd like to welcome you guys that weren't able to be in class today. I'm going to video the lesson for today. Then I'll put this on my YouTube channel, and then I'll put the link to my YouTube channel on the Google Classroom, so that you'll be able to see what we're doing today and stay caught up. Hopefully, those of you who aren't feeling well start feeling better. And if you have any questions, just give me a holler at my email, or you can call here and I'll try to answer the phone. All right, so what we're talking about today, we're going to use what we knew about integer exponents that we learned last week, and we're going to take those integer exponents and look at a new problem. We're going to do squares and square roots, right? And we're going to develop the definition of a square root. We're going to know what a perfect square is. We're going to know what the square root of x is. We're going to know what the cube root of x is. We're going to know what a perfect cube is. We're going to look at prime numbers, and we're going to talk about what a base is when we're talking about a shape, not a power, right? So, but today we're just going to talk about squares and square roots. So the length of each side of a square measures s inches long. The area of the square is 49 inches squared. What's the length of one side of the square? So what we're looking at is a square, right? We're looking at a square. And that square, we know that on squares all the sides are the same length. This square is 49 inches squared. That's the area. And the sides are s inches long. So what we have to do is find out how long each side is, and we're going to look at what we're going to do. So we're looking at the area of the square being 49 inches squared, area equal 49 inches squared. And we're going to try to find the length of one side. So what we're looking for is s. We're looking for s equals, right? So this is the picture that's on there. I just kind of added some stuff in to give you a little extra information. Now we're going to answer some questions, but I need to move the up a little. All right. So now what we're looking at, question A, it says describe in words how to find the area of a square given that each side is s inches long. Well, how do you find the area of the square? Right? If we have an area of the square, we're going to multiply s times s. So the answer to A in words is multiply s times s. Right? So we know that a square is length times width, and since both sides are the same, it's going to be s times s. Now we need to write a multiplication expression using the variable s to represent the area of a square, right? So when we write that, we're going to write s, so B is going to be s times s, right? S times s is the actual the number sentence, the variable sentence, multiplication. This is the same thing in words. This is multiply s times s. Right? Then we want to write an expression using the variable s and exponent to represent the area of the square. Well, s times s, remember we talked about exponents when we had a base, 2 times 2, that was 2 squared. Well, with variables it works the same, right? So this would be s times s is going to be s squared, right? S squared. But now we need to write an equation. This is just an expression. This expression just says that I'm multiplying s times s, just like this. But now we want an equation. Well, equation means something is equal to something. In this case, s squared, s times s, is going to be equal to the area of the square. So we have d, which is s squared, is equal to 49 inches squared. Now, one thing we have to understand is that when we multiply something that has a value, a measurement, we also have to multiply the measurement. So this is really S inches and S inches, right? I know it looks like the word sin, but it's S inches, all right? And so we wrote that, and we're representing the area of a square, right? That was the expression. Now we're doing the equation. Now, E says to consider the factors of 49 and explain what the two sides of the equation have in common when you write each as a product of the two factors. Well, when we do a factor tree for 49, right, 49 has actually four factors. 1 and 49, but that's not going to do us any good if we just write 1 and 49. And the other factors are 7 and 7, right? So what does that mean when you write it as what does two sides have in common? When you write it as equation two factors, the sides are the same. Each side can be written as something times itself, right? Right? So 7 times 7 is going to be anything times itself, right? It can be, you use each and you write the equation as a product of something times itself. Well, that means we're looking at 7 squared, right? So S squared is equal to 49, right? It's also equal to 7 squared, right? So S squared, E, S squared is equal to S times S, which is equal to 7 times 7, right? And I hope everybody understands where that came from, all right? So now what we're going to do is we're going to go to the back page, the next page, and we're going to find out what we mean when we say S times S and 7 times 7, right? So this find out more section, 49 is one of a set of numbers called perfect squares. A perfect square, by definition, is a number that results from multiplying an integer by itself. Everybody remember what integers are? Integers start on a number line at 0, and they go infinity in this direction, and they go infinity in this direction, right? So they're numbers, not fractions. They are not decimals. Their integers are just numbers that go in both directions, positive and negative, from 0 to infinity in both directions, right? So a perfect square is simply an integer multiplied by itself, whatever the result that you get. So just a few examples. You can see the chart that's in your book on, I think it's page 15, right? And it's the first 15 squares. Now, I want you to learn the first 25. So, because I just think it'll help you more than just learning the first 15, right? So, let's take a look at what we're talking about. An integer is a number, 6 times 6, that's equal to 36, all right? Or negative 6 times negative 6, which is also equal to 36. Both 6 and negative 6 are integers, right? Which shows you that squares actually have two solutions. If you take the square root of a square, like 9, it can be either 3 or negative 3. Now for us right now, because we're talking about the length of a side, we're talking about the positive square, the positive root, or also known as a principal root, right? So in this case, what we're looking at are all these perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and then the final one is 15 squared, which is 225. And the good thing about these is these will work also when you're doing decimals, right? So 15 squared is 225. 1.5 squared would be 2.25. So you can still use this chart even when you're doing decimals, right? So if we look at the equation we were on the previous page, you have s squared is equal to 49. How will we solve that equation where a variable is squared is equal to a perfect square? And we've done this through when we're doing addition or subtraction by using inverse operations. Well, the inverse operation of squaring something is to take the square root, right? So what I'm talking about a square root, the inverse operation squaring is taking the square root. A perfect square is when you multiply an integer by itself. The square root of a number is a number multiplied by itself that will give you that number. In this case, 49, right, is equal to 7 times 7, right? And the key for this is that this number is going to be an integer because these are perfect squares. There are others that aren't perfect, and we'll find out how to find those square roots in another lesson. But for right now, we just need to know how to do perfect squares, right? So the inverse of a square number is called the square root, right? And it says it there in your book, right? The square root of a number is any number that you can multiply by itself that will give you the original number. So look at the example. It said 3 is the square root of 9 because 3 times 3 is equal to 9. Another square root of 9 is negative 3 because negative 3 times negative 3 is also equal to 9. Remember, a negative times negative gives you a positive. The symbol for square root is right here. It's called a radical, right? That radical means the positive square root in the math that we're talking about right now, right? So for the positive root, right, for 9 is going to be 3. So the square root of 9 is going to be equal to 3 for our purposes. Okay, and remember, you can always stop this video and go back and answer questions, right? So let's look how that works, right? So we have the square root of 49, right? The square root of, we have s squared is equal to 49. Then we're going to take the square root of 49, we get plus or minus, right? Plus or minus the square root of 49 is going to give us plus or minus 7. Now, here's the question that we have. We're talking about a square, are we not? If we're talking about a square, right, is it possible to have a measurement of negative 7 on a square? Well, the answer to that is no. It's not possible because it's distance, a length. Length is always going to be positive, so we know that we don't have to worry about this. We don't have to, even though it says plus or minus 7, we don't have to worry about the minus part because you cannot have a length that's a negative number, so we know we're only going to worry about the positive root, right? So it gives us the length of one side of the square is 7. So the square root of 49 is equal to x squared. Well, actually 49 inches squared is equal to s squared. So we take the square root of both sides. Because remember, what you do on one side, you have to do on the other. And that gives us 7 inches times 7 inches, right, is equal to, would be equal to 49 inches squared, right? So if those are equal, the square root now is just 7 inches, because remember, inches times inches gives us inches squared. When you do a measurement, you always have to use the number and the measurement in order to be correct, okay? So what I want you to do is look back over what we've talked about so far and then use that to answer this reflex question, right? The reflex question says simply, what is the difference between dividing 16 by 2 and finding the square root? What is the difference between 16 divided by 2 and the square root of 16? Okay? So the way you can think about that is you go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. If I was going to divide 16 by 2, I could just do 4, 8, and draw a line down to there, and I've divided them into two groups of 8. Right? So the answer to 16 divided by 2 is 8. Right? But when I'm looking for the square root of 16, well, I'm looking for a number times itself that's going to give me 16. And the key to that is the word square. Right? The word square. So what number, if I square it, will give me 16? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Look at the shape. It's a 4 by 4 square. So the answer to the square root of 16 is that the square root of 16 is equal to 4, because 4 times 4 is equal to 16. Remember, square root, 4 times 4 is also called 4 squared, and the square root and squared, 4 squared. So the square root of 16 and 4 squared are inverse operations. All right? Any questions on this? All right, so your homework for tonight is page 13 and 14. All right? And again, if you have any questions, you can run this video back and forth as long as you want to. Right? I will save this to my YouTube channel, and I'll post the link in the Google Classroom. All right, y'all have a nice night, and I hope you feel better.